Check it.
Okay, welcome back. Today we're doing day 2 of lesson 6.3. We learned about end behavior and we learned about power functions last time. Now we're going to learn how to graph functions in factored form. So let's say you have a function like this. Now we know how to graph something like this with a table. We've done this before, but what if you just factored it, right? So you can see that this is easily factorable with reverse FOIL. And let's see, we have x and x, right? Two numbers that multiply to give you negative 15. 5 and 3 should do the trick, right? And the 5 has to be negative. So if you multiply that out, you will get this. Now that it's in fully factored form, okay, can you tell me some things? One, can you find the roots or the zeros, okay, also known as the X-Intercepts? What are the X-Intercepts? Well, we learned previously that if you have something in factored form and you want to find the X-Intercepts, you just make the Y 0, and that lets you use the zero product rule, right? So we'll do that. If we use the zero product rule right now, we can see that x minus 5 equals 0 gives us x equals 5. That's one X-Intercept. And if we set this equal to 0, we get x equals negative 3. And there are our X-Intercepts. So not too difficult. Just set the factors equal to 0. Now, can we find the Y-intercept? The Y-intercept. How do you find the Y-intercept? The Y-intercept is what you get when you make the x 0. So here you have the function, right? Now you can do this here or you can do it here. If you do it in factored form, that becomes a 0, that becomes a 0. And now what you have is y equals negative 5 times 3, which is what? Negative 15. So your Y-intercept is going to be negative 15. Okay, or as a coordinate, it's 0, negative 15. However, if you had done this up here, you made this a 0, that becomes a 0, made this a 0, you can see it's just going to be negative 15, right? So either way, factored or not factored, you get a negative 15. So let me come back to here. All right. So we have our X-intercepts, we have our Y-intercept, and we can put those down in the graph. Now, here's the thing. Negative 15 is not going to fit on this graph. And that's going to be a problem with all of the functions that we graph today. The Y-intercept tends to be really, really off the graph. So we're going to kind of fudge it and just squeeze it onto the graph anyway. So let's see, our X-intercepts are 5 and negative 3. So 5 is 1, 2, 3, 4, 5. Okay, just label the intercepts, just label the points that you're graphing. And negative 1, 2, 3. Notice I'm not numbering everything. I'm trying to save time here. And what's my Y-intercept? It's negative 15, which would be way down off the bottom of the graph, but I'm just going to stick it right here. Okay, so the Y-intercept does not have to be to scale. Okay, because that's going to happen on every single problem today. Okay, so we have 3 points here. What does this thing look like? Right? Well, we also know end behavior. What is the end behavior of this function? Well, if this is a second power function, it's an even power. Okay, second power, so it's even. And if it's even, all right, it's going to be one of these, not one of these. An even powered function, both of the ends go in the same direction. The end behavior is either up, up, or if it's negative, down, down. Okay. If it's an odd powered function, we learned that it's going to be one side up, one side down, one side up, one side down, depending on whether or not it's even or odd. So, or positive or negative rather. So we know this is even, that means it's going up, up, and there's no negative in front of the x squared, so it's up, up. So it looks something like this, in this direction like that. So if we know that, we know the end behavior is up on both sides, we can go over to the last X-intercept and just go up from each one. So this is, from here we know we're going up, and we know we're going up. That's where the end behavior helps us out. And now you can kind of guess what the middle looks like. The rest of this just kind of comes down, have to go through the Y-intercept, but then it's going to have to come swinging back up and come up through here. Now, do we know exactly where the vertex, the center is? No. We'll need a table for that. And that's how we used to graph. We used to use a table. But this is just a sketch, okay? And this is good enough. for what we're doing. All right, so we have a sketch of this function based on the x-intercepts, the end behavior, and the y-intercept. And we know the y-intercept is not in the right spot, but that's okay. All right, so there you go. Let's try another one. Now this one is already factored for you. And that's what we're going to be doing today. I'm going to be giving you functions that are already factored, and you don't have to do the factoring yourself. You just have to deal with them as they appear. So this one here is got 4 factors, okay? And we're going to do the same thing. We're going to find the x-intercepts, the y-intercept, the end behavior, the degree and the end behavior, and then we're going to do the graph. Sketch the graph. So let's do this. Now, if we have something fully factored like this, if it's already written as factors, we don't have to factor it. So you're welcome. That's done for you. How do you find the x-intercepts? Well, you assume that y is 0, and you know that whenever you have a whole bunch of factors multiplied to give you a 0, you can use the 0 product rule. So that means x plus 2 equals 0, x plus 3 equals 0, x minus 5 equals 0, x minus 1 equals 0, and you solve those little mini equations, and you get x equals -2 from here, x equals -3 from here, x equals +5 from here, and x minus 1 equals 0. When you add 1 to both sides, you get x equals 1. So we have 4 x-intercepts, and they're going to be over here. So -2, -3, +5, 1, 2, 3, 4, 5, and +1. So that's our first step, putting down the x-intercepts. What's the y-intercept? The y-intercept is what you get when you make the x's 0. So if this was a 0, and this was a 0, and this was a 0, and this was a 0, this would just become y equals 2 times 3 times -5 times -1, because all the x's went away, right? And if that's the case, what's the y-intercept? 2 times 3 is 6, 6 times -5 is -30, and -30 times -1 is +30. So the y-intercept is 30, or 0, 30 written as a point, and that's going to be way off our graph. So we're going to fake it. We're just going to say, all right, let's say that's 30. Okay? We have to do this with these problems because all the y-intercepts are way off the graph. So we have our intercepts now. What's our end behavior? What degree is this function? And thus, is it an odd or even powered function? Is it a Rocky or is it a Travolta, right? So how do we tell? If you look at this up here, okay, you have an x times an x times an x times an x. So what degree do you think it's going to be? Well, when you multiply all these out, you're going to get a 4th degree function, okay? X times x times x times x. So this is a 4th degree function, right? Which means if that's a 4th degree function, it's an even function. So it's a Rocky. It's one of these, right? Where both are going in the same direction up. So since we know that, we can come over here and say, all right, at the very ends of this function, after it passes through the last intercepts, it's going to be going up on the left and up on the right. Now make sure this is a curve, not a straight line. Don't do this. Don't go like that. It's not a line. We're talking about a polynomial here, and polynomials are always smooth, curvy line. Like they're not lines, they're curves. Okay? So no part of this should be pointy. You should not have anything that looks like that. You should not have anything that goes kind of vertical like this. That should never, well, it's not exactly vertical, but yeah, you can't be like straight up. That doesn't work. It has to be something that basically looks like one part of a parabola. It has to look curved to some degree. Now the question is, what do we do in between now? How do we connect all these dots? Okay. The end behavior is up and up. So we know that. And now we can zoom in on this graph here. And we have to find a way to go through all of these points. So it's kind of like a drawing game at this point. How can we go through all of these points in a nice smooth kind of way? Well, let's see. Starting from the left, our end behavior is up. Going to come down, going to go through this first x-intercept, and then we're going to curve back up and go through this x-intercept. Okay? then we have to go through this y-intercept here. So come up, go through the y-intercept, curve back down. You're going to come through this x-intercept, curve back up, and there you go. Now, if you made a mistake, this wouldn't work out very well. But since I didn't make any mistakes, it just has a nice smooth flow. And there you go. No corners, no straight parts, no vertical parts. So that's your basic problem right there. Now, sometimes you have even more factors, and sometimes some of the factors are repeated. So we're going to come down to this problem down here. Now, this problem, it's fully factored for you, because if you had the factor, if you know, this is, let's see, what degree is this function? How many x's do we have? We have x to the 1, 2, 3, 4, 5, 6, 7. This is a 7th power or 7th degree function here. So if I give you a 7th degree function and told you to factor it, that's a nightmare. But I've already factored it for you. But you'll also notice that some of the factors are repeated. Like for instance, here's an x plus 2, and here's another one. And also, here's an x plus 3, and here's another x plus 3, and here's another x plus 3. So some of the functions are repeated. They recur more than once. And what we say is that these factors that are there more than one time have a multiplicity. Okay, multiplicity meaning they're happening multiple times. So this has a multiplicity of 1, 2. There's 2 of those x plus 2 factors. And for the x plus 3s, there are 3 of them. So what are our x-intercepts? X-intercepts. Well, from this one, you get x equals -2. But there's 2 of them. So it's a double root. Okay, there's 2 of them. This has a multiplicity of 2. Okay, meaning it's a double. For the x plus 3, you get x equals -3 as your x-intercept. But this is a triple root. It has a multiplicity of 3. And then you have an x equals 5. And then you have an x equals -4. Actually, you know what? I'm going to change something because these are all going to be really crowded together. Let me make this -1. Okay, so we'll have, that'll create an x equals 1 here. Okay, I don't want too many of them crammed together on the graph. Okay, so now we have our x-intercepts. What's our y-intercept? Well, our y-intercept is what we get when we plug in 0 for all of these. Okay, and that means we're going to be getting y equals 2 times 3 times -5 times 3. Well, actually, you know what? Let me do this a little bit an easier way. So another way I could have written this right here, all right, instead of having all 7 written out like this, you could also have grouped together the like factors. So x plus 2, there's 2 of them. So instead of writing it twice, just put a second power on it. And x plus 3, there's 3 of them. Just put a third power on that. So x plus 3 3 times. Then you have your x minus 5, and you have your x minus 1. And if I gave it to you this way, would you know that this was a 7th power function? Because here you had 7 x's, right? Would this still work here? Well, what you do is this. This x is happening twice, so that's 2 x's right there. This x is happening 3 times, so you have 3 of them there. That's a total of 5 x's, right? 5 right there. And then you have 6 and you have 7. So it's still a 7th degree function. You just have to take into account the powers here. And now when you go to do your y-intercept and you make all of these 0, that becomes a 0, that becomes a 0, that becomes a 0, that becomes a 0, you'll get your y-intercept is, you get 2 squared, 3 to the third, -5, and -1. So that's going to be 4 times 27 times, well, this is going to be +5 when you multiply both of these. And that's going to be a pretty big number. It's going to be 540. So our y-intercept is 0, 540. There's no way we're fitting that on a graph. So we're just going to fake that one. We'll put it down, but it just really won't matter where it is. Okay? So the fact that this is a double root, it has a multiplicity of 2, is going to change the way you graph this thing. So I'll show you what I'm talking about. Let's put down our x-intercepts. So our x-intercepts are -2. This is going to be -3. This one's going to be 5. 1, 2, 3, 4, 5. And this is going to be 1. The ones that are repeated, that have a multiplicity, okay, a multiplicity of 2 or more, you have to look at them and say, all right, if you have a double root, or if it's a multiplicity of any any even multiplicity basically. So this has an even multiplicity. Okay, if it's a double, meaning 2, or a quadruple, meaning 4, or 6 or 8 times, anytime you have an even number of roots, you're not going to pass through that X-intercept. You're going to bounce off it. So you're going to bounce, not pass through. Even multiplicity means bounce. So do we have any even multiplicity? Yeah, this one right here, -2. So come over here, and what I'm going to do, just to kind of like remind you that this is a special root, I'm going to put a little purple circle around the root there. So we're not going to go through that one. We're going to bounce off of that one. So you'll see what I mean in a minute. Okay, what's the end behavior? Well, we said that this was a 7th power function, right? This is a 7th degree function. So it's an odd function, right? It doesn't have a negative at the beginning, so it's upright. So it looks like this. Typical odd powered function, just like that. Okay, up on the right, down on the left. So what does that mean? It means that on the right, we can go up, and on the far left, the last X-intercept is going to go down. But what happens in between now? Well, if you didn't bounce like I said you're going to, watch what would happen. Oh, by the way, our X-intercept is 540. So I don't know, let's just put 540 right here. Okay, we're going to have to go through that. So watch what happens now. If you went up through here like you're supposed to and go through here, there's no way for you to go through this Y-intercept because now you're on the wrong side of the X-axis. The only way to get up here is to cross the X-axis again, but now you've created an X-intercept that doesn't exist. So something's wrong. Something's not working here. Okay? And what's wrong is that you're not supposed to go through this purple one. You're supposed to bounce off of it. So here's what I mean by bounce off of it. Okay? You're going to come through here, and then you're going to come back down, but you're going to bounce like that. Without going through it, you're just going to bounce off of it, and then you can continue going through the rest of these as normal. So that's through, and then that's through. And you can see now everything makes sense, everything works. So the moral of the story here is, if you have a double root, meaning 2, or 4 of them, or 6 of them, or 8 of them, those roots, those X-intercepts, you bounce off of them. You touch the X-axis, but then you don't go through it, you just bounce off. All right, last one. So this one's fully factored, and it's grouped together, meaning I didn't write x plus 3 twice, I wrote it x plus 3 to the 2nd power. I didn't write x minus 1 3 times, I just wrote x minus 1 to the 3rd power. So there you go. What's the degree of this function? Well, you have an x here, but you have 2 of them. So that's what that means. This is actually x plus 3 twice. So here's 2 x's. Here's another 3 of them, that's 5 in total. And there's one more here, that's 6. So this is a 6th degree function, right? So that's an even degree, meaning it's supposed to be a Rocky. However, there's a negative here. See this negative right here? So it's actually not an upwards Rocky, it's a downwards Rocky. It's a downwards even powered function like that, okay, because it's negative. So there's your end behavior and there's your degree. Now, what X-intercepts, okay? Well, let's see, if we set each one of these equal to 0, we're going to get x equals -3, and that has a multiplicity of what? Multiplicity of 2. Mult of 2. That means you're going to bounce. Okay, don't forget that. It's an even multiplicity. Any even multiplicity, you bounce. Any odd multiplicity, you go through. So this one here is going to give us x equals 1, and it has a multiplicity of 3. That's odd, no bounce. Just go through. And this one here, x equals -5. Now you may say there's no multiplicity at all, but think about it. That's a power of 1, which is odd. So if you think of it as a multiplicity of 1, although it's a little unnecessary to think of it that way, this is an odd multiplicity, so you're not going to bounce. Okay, so all of the terms that don't have little powers on them, you go through. All of the terms that have odd powers on them, you go through. And all the terms that have even powers on them, you bounce. Okay? Now, if we had time, we'd go into more of the shapes. The higher the power, the more it kind of wiggles through, but we're not going to really talk about that on this lesson. So let's just go ahead and, in case the teacher's watching, yes, I am skipping that intentionally. All right, so let's go ahead and put these on the graph. So x equals -3 is right here, and it's a double multiplicity of 2. That's going to be a bounce. So I'm going to circle that with a purple. I'm making purple my bounce color here. All right, purple circle there. We have x equals 1, which is here. That's got a multiplicity of 3, so we're just going to pass through it. Okay, technically you're supposed to wiggle through it, but we'll talk about that some other time. And x equals -5, that's going to be over here. And there we go. Those are our x-intercepts. What's our y-intercept? Well, there's only one y-intercept because there's only one y-axis. The y-intercept is what you get if you make all these x's 0, and then you simplify. So here's the thing, that negative is still there. But now this becomes a 0, that becomes a 0, that becomes a 0. So this is going to be negative, because of that negative there, 3 squared, -1 to the third, and 5. So that's -9, negative, then 9, then -1, which is +9, and +9 times 5 is +45. So our y-intercept is 0, 45, which is once again way off the graph. So I'll just fudge it and say, let's say that's 45 right there. Now, we have all of our x-intercepts, we have our y-intercept. What's our end behavior? Our end behavior is down on both sides. So going to your last x-intercept on each one of these, just go down and down. Okay? And make sure that it looks like a curve, not a line. Now, connect the dots, but remember to bounce on the even multiplicity. So if I forgot to bounce, watch what would happen. I'd go up, I'd come down, and I'd be stuck down here, and how am I supposed to go back up here? I would create another x-intercept that shouldn't be there. But once again, just like last time, we're going to bounce. So come up, bounce off of that, and then you can finish your graph, and everything should make sense at that point there. The end behavior is correct. Down, down. The x-intercepts are all correct. We had a multiplicity of 2, so we bounced. The y-intercept is not to scale, but it's good enough. All right, we're good. See you in the next video.
Check this.